not scared?
That was flat to the boards.
Oh, really?
Yeah.
Oh, that's awful. And you're not even getting to red line.
Nope.
Oh, that's... I'm
I mean, I would
surprised.
have got there eventually.
Yeah, but I'm surprised that that was flat to the boards. I'm surprised.
So we were able to road test our 76 911 Turbo, and it was really not performing well. Car ran strong under 3,000 RPM. Problem was we didn't get any boost whatsoever. Car would rev to around 5,000, 5,500, still not developing any boost, and in fact, power dropped off. So the owner of this particular vehicle had a different set of cams installed, and he had some pictures on the cam timing that the cams were set at. So he was able to send those to us. Looking at the pictures, where it is timed for the cams that are supposed to be in it, and that's still a question mark because we really don't know for sure what cams were installed. They were a used set of supposedly SC cams, which is a common, I'm going to call it an upgrade, but it's not always an upgrade. A common install on these cars, and the timing, they are extremely retarded. So that will cause boost pressure to not generate and will move the power band back. So what we're going to do now is we're going to pull the intake off again, pull the exhaust off so we can get access to the timing covers, pull the valve covers, let's get a dial gauge on it, confirm the valve timing first, that I believe it is, and see what it is, and then we'll have to get in and see what cams are actually in this. Hopefully they have not been reground. So we are going to do all this work in the car. We're not going to pull the motor. We will lose a little bit of oil, which is to be expected, but it is completely doable. It looks bad, but it's okay. So the first thing I want to do is confirm the reading is what the pictures that were sent to us is on the car. So I'm set up on number 4 only because it's the easiest one to get to. And if number 4 is out, then odds are number 1 is out. I'll still confirm it, but right now I have checked the valve lash. It was perfectly set at 0.1 using our valve lash tool. 0.1 of a millimeter. All of these measurements should be done in millimeters, not thousandths, because it just adds a chance for a mistake to happen, which is what I believe has contributed to this issue. So the number that we were supposed to see is 0.4 of a millimeter at TDC, and I've got my crank pulley is on the TDC mark, which is this yellow one. And on my dial gauge, I'm actually reading 0.42 of a millimeter is the valve opening. And I'll show you that in real time in just a minute. But that confirms the number that was sent to us as 0.4 of a millimeter at TDC. Now, the timing for the camshaft that's supposed to be in there, the ideal number is a 1.55 millimeters of lift with a 0.1 valve clearance. And that's going to mean that this cam is extremely retarded. Now, on a regular turbo cam, the timing spec is 0.65 to 0.8 of a millimeter, with 0.72 around there being optimal. So even if this was a turbo cam, it would be slightly retarded as well. So let me run it all the way back to TDC. Let my dial gauge run back to 0. Confirm my 0. Okay, so right now we've got my dial gauge is back to my 0 point, exactly where I left it. I am on TDC number 1 overlap, so that means number 1 intake and exhaust valves are tight. Number 4 is loose. And I'm just going to rotate it round again, so another 360 degrees of crankshaft revolution. Okay, coming up on TDC now. Dial gauge is starting to move. There's our TDC point, and that time I got 0.44, maybe a slight difference from where I'm at down here. It looks like I'm slightly past the mark on the crank there, but confirms that the cams are retarded. So we are going to go in now. We got to take off all the underside stuff. I've got the intake manifold stuff out. I've got to pull all of it out so I can get to the timing covers, get the covers off, and adjust the cams. I've pulled all of the exhaust off for the turbocharger, so the pipe that wraps around with the wastegate. Turbocharger's out, and now we've got pretty good access to our timing covers. So just got to pull the tensioner pipes off, get the covers off, and see what cams we got in it. So moving forward on our retime project. Okay, so before I change my cam timing, I wanted to get an idea of how far out, and I've still got to verify the cams, but what I've done is I've set my intake opening to 1.55 millimeters open, which is what it's supposed to be for the cams that are supposed to be in there, and that's a big unknown right now. When I look at my crank pulley, the yellow mark down here is my TDC. And here is where it should be aligned with, right there on the alternator housing. When I measure from here to here, this measures 16 millimeters. So I know the diameter of the pulley, and the math works out that 1 millimeter is equal to 1.09 degrees. So when I do the actual math, the timing on these cams is retarded by 17.5 degrees, which is quite a large number. So instead of the intake valve opening at 7 degrees before, it was opening at 10 degrees after. So that's going to move that power band considerably. So the next step is I'm going to pull this cover since I'm set up on this side already. I've got the pipe off of here for the oil feed to the tensioners. Just going to lift it back up, pull the covers, and undo the nut on the front of the cam so I can read the cam. This I know has later cams in it, so instead of using the 46 millimeter nut, it's got a late style which uses the 19 millimeter bolt. As soon as I get that off, I can get the number on the cams. But because these were used cams, it doesn't really mean a whole lot. All we can do is retime it, redrive it, and see what it feels like. 148.10 means the left cam should be a 930/147.10.
What do we have?
148.10 is the right camshaft. So this is for a 911 SC. Let me go set the timing.
That's right on. And then, did that stay where you wanted it to?
Yep.
Great.
I'm just going to find an available hole. Let's look at the cam.
Ooh, it's going crazy now. And settling.
Back to 0. Okay, that's TDC number 1.
One more full circle. It's coming up.
Okay, it's moving. Looking for one full revolution first. .52, so that's a split of 0.04 of a millimeter, so I can live with that. So when I looked down here at my timing mark, I wasn't happy with the space, with how it was aligned with the notch, so I kind of worked it a little bit more, got my notch alignment exactly where I want it, and my timing is now 1.56 millimeters, which is exactly the same as the other side. So all I got to do now is put it all back together and redrive it. I'll probably look at fuel mixtures again and make sure they're all doing what they're supposed to be doing with the cam change. After resetting the valve timing and test driving the car, it was a lot better, but it still wasn't doing things too well. So one of the things I did is just brought it back and went, okay, we're gonna take a breath and just go back over and check some other things, back to our basics again. One of the things that always bothered me about this car is the valve assembly, which I'll show you here in a minute. I could never really hear it moving too well inside the intake manifold. And a lot of that we kind of put down to, well, is it getting enough intake manifold vacuum, or is there something going on there? But one of the things I wanted to do is just look at our throttle. So I have a stop inside the car, and our throttle is held all the way down, yet we are only getting about 2/3 throttle. So I need to go underneath and look at the pedal box and take a look and see why that gas pedal is not getting full throttle. So back to our piston right here. I ended up pulling the whole manifold off. I did loosen this end cap, which I can get to in the car, just to take a look, but I couldn't really see too much in there. I thought I could see the spring. And the purpose of this piston is to change the length of the intake manifold. If we take a look down here, we can see the piston where it's sitting and it's blocking off. And right now, with no manifold vacuum, it's making this manifold very long. So this is the sensor plate here. This goes to the turbocharger out this end. And then this is where it comes back up from the turbocharger through this manifold and into the engine. So when manifold vacuum is applied right here, what it does is it sucks this piston back. There is a spring and a guide tube in here, and this piston moves backwards and forwards. Now, normally when you rev the car, you should hear like a thok, thok as this piston moves back and forth, and that's because as manifold vacuum goes away, spring pressure overcomes manifold vacuum, piston goes down this way and makes the manifold longer, which makes it better for high-end performance, but a shorter manifold is better for low-end torque. So under 3,000 RPM, you want a short manifold, in which case air is being drawn in through the turbocharger, and it's short-circuiting the boost side, and it's being allowed to flow directly into the intake manifold and into the engine. So with this piston, which I found was installed backwards, spring was down this end, piston was up this end. So when I got it off and was able to look in here, all I could see was spring and the guide tube. What would have happened is when I came on to boost, boost is going to have as much opportunity to create a loop as it is to force into the engine, because this connection between the two manifolds was open. So that's going to make, I believe, the biggest and a huge difference. Just finding lots and lots of things wrong on this car. So the speedometer does an interesting thing on this car. Put it in neutral, take my foot off the clutch, and pull the parking lights on, and we're at 50. Full headlights, we're at 70. Oh, high beams are on. There's high beams. A little over 70 miles an hour. So there's obviously a wiring issue where it's picking up an inductive current. The speedometer appears to work, but I thought that was kind of amusing. I can do 50 miles an hour sitting still in my driveway.
Feels better than the last time already.
Oh, this is how it felt
Yeah.
before.
Oh, like
After
second.
just resetting the cams made a huge difference to low end torque.
Oh, it's awesome. What a difference already.
That was just resetting cam timing, fixed the under 3000, made it super responsive.
Yeah, it's so much better than last time. Well, yeah,
Boost.
yeah. This is what I expected. Like trouble.
Shouldn't do that on dirt road, because I think I just spun the wheels.
Oh, yeah. Let's get on the tarmac. Why's this brake light stuck on?
It's a wiring issue. The switch is all loose, and I think the wire's pinched.
Okay. All right. Oh shit. Sorry.
The boost limit.
Okay. Well, you didn't hit the end of it that time.
No, I controlled it on the throttle and held it.
Yeah.
It's a brand new engine. But it's definitely got boost now.
Yeah. I'm scared.
Good.